Good morning, class. We are looking at exam 3 review, covering chapters 3 and 4. Chapter 3, we cover from 3.9 to 3.11. And chapter 4 from 4.1 to 4.5. Here's covering chapter section 4.1 and 4.2, 4.1 maximum and minimum values. 4.2, the mean value theorem. So we're covering 4.1 and 4.2. In this section, we're going to cover all the way to 4.5. So ultimately, we get to how derivatives affect the shape of a graph, indeterminate forms and L'Hopital's rule, summary of curve sketching, and we leave the rest of them for the next exam. So let's get started with a very basic definition. So 4.1 maximum and minimum values definition, critical point or short CP, a critical number or point of a function f is a number C such that f prime is either 0 or f prime does not exist. Therefore, the process has a few steps. Number 1, find f prime of x. Number 2, set it equal to 0 and find the solution. Number 3, look for where f prime does not exist. For example, if it's a rational function, what makes the denominator 0 makes it undefined and it doesn't exist. So find the critical numbers for f of x equals x to the power of minus 2 times ln x. And the very first step is to differentiate. So we need to put a raised dot here because we are going to use the product rule. So if you call this F, you call this G. I highly recommend you write the formulas. I'm assuming you have memorized the formulas. So when you come across a question from the memory, write your formula and apply that. So x to the power of negative 2 gives you minus 2, x to the power of negative 3, that's the power rule, times ln x, plus g prime f. The derivative of ln x is 1 over x times f, x to the power of negative 2. And we are done. We are going to just rewrite this. So this becomes minus 2, x to the power of minus 3 ln x. And this becomes x to the power of negative 3. Now, we can, since we want to go through this process, we can factor out x minus 3. And this leaves us minus 2 ln x. This leaves us 1. And we take the x minus 3 down and we make it into the following fraction. Now, that was the first step. Now, the second step says f prime is 0. We want to set this equal to 0. A fraction is 0 when its numerator is 0. So if we set this equal to 0, that means the top is 0. And that means you take the 1 to the other side and you divide by negative 2. ln x becomes 1/2. I'm assuming that's easy. Now, you go to the definition. Remember, when we don't have a base with ln, the base is e to the power of 1/2 is x. And that is the precise answer. If they want an approximation, you put it into a calculator. This is not missing, E is not missing. It's just a number, but that's a precise answer. So square root of E is the answer. Where f prime doesn't exist, the last part is the denominator. You set the denominator equal to 0, and x becomes 0. However, that is not an acceptable solution. Why is that? Because if we go back to the original function, the original function is ln x over x squared, and the domain is from 0 to infinity for ln x, and 0 is not included. I hope you remember that from. So this, the domain is restricted with the domain of ln x, which is 0 to infinity. So 0 is not included. Please understand, for x to the power of -2, which is a rational function, the domain is all real numbers except 0. Okay, but always we go with the more limiting factor. All right, we are going to go over max and mean points on a curve, and here's the definition. Local, also known as relative extrema. Extrema means both max as well as mean. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of A to B in the domain if f of c is less than or equal to f of x for all x values in that open interval. So this is a local mean. By the way, this is a local max. A local max is the maximum value within some open interval. Local maximum occurs at the point C in an open interval of A to B in the domain if f of c is larger than or equal to f of x for all x values in the open interval. So remember, local or relative. So this is local mean, this is local max. And now, as far as the absolute is concerned, or global, extreme values or extrema are either maximum or minimum points on a curve. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. So this is a local mean, local max, local mean, but this one is also an absolute mean because no other point has a smaller y coordinate. Absolute max occurs at the point C if f of c is larger than or equal to f of x for all, and that's the key, all x values in the domain. So this is local max as well as absolute max. So I want to make sure we understand what's going on. So quick recap. Local mean, local max, the peaks and valleys. Local mean, local max. Local mean, local max, local mean. But this one is also an absolute minimum. Local max, local mean, local max. Again, peaks are max and valleys are mean. So local max, this one is also an absolute max because no other point has a larger y coordinate. Now, in this example, we want to find the absolute max and minimum value of f or f of x, if you will, in the given interval. So f of x is 1/3 x cubed minus 9x, and this is minus 6 to 0. This is called closed interval method. Closed interval. So if the function is continuous and if the interval is closed, then we can go with this methodology, which I'm going to discuss in a moment, and find an absolute max and absolute mean. So a function which is continuous, and we have a closed interval for it, we can use the extreme value or closed interval theorem and find an absolute max and absolute mean. It must have a both. And what's going on here? This is a polynomial of degree 3. Polynomial of degree 3 is continuous from negative infinity to positive infinity. Every polynomial is continuous from negative to positive infinity. Therefore, it's continuous in the given interval of -6 to 0. Therefore, we're going to go with the methodology. The methodology says, first find the critical points. So what are the critical points? Well, first let's differentiate. To find the critical points, we are going to differentiate f prime of x, f prime of x is x squared minus 9. We set this equal to 0 to find CP, short for critical points. CP, critical points. CP, and then we have S. All right, so set this equal to 0, x plus 3, x minus 3, set equal to 0, x is either negative 3 or positive 3. F prime doesn't exist. F prime doesn't exist, doesn't produce any solution. This is phi, which represents an empty set. It's a Greek letter, phi, which means an empty set, meaning because f prime itself is a polynomial, it exists everywhere. That's the concept. So there are only two answers. Now you go back to the given interval. Is negative 3 in between? Yes. Is positive 3 in between? No. So you can only use negative 3. And this is an element of, looks like an epsilon. You may remember it from set theory. This is read an element of. So it's an element of. So with that being the case, we are going to evaluate this function at -6, at 0, and at -3. I'm assuming nobody has any problem with that. Just plug in -6, do the math. Plug in -3, do the math. Plug in 0, do the math. So we found that. The second one is find f of a, this is a, f of b, this is b in this case, f of c1, c2. However many critical points, there's only one critical point. That's why I put f of a is f of -6. F of c is this number that we found, and f of b is f of the one of the other endpoints. There are two endpoints, a and b. The largest value is the absolute max. The smallest value is the absolute mean. So 18 is the absolute max in this pair, and -18 is the absolute mean with this pair. And again, when you answer the question, you want to answer it accordingly, however they ask you to answer it, okay, in order to receive full credit. We're going to repeat the same type of question, and this is a closed interval theorem. And we have to justify the answer whether or not this is continuous from -4 to 5. And to do so, you have to recognize the function. The function is the cube root of x plus 3 squared minus 5. So I hope you realize that in essence, it's a cube root. That's the function that you're interested in. Of course, you square, then you subtract 5. You can obviously graph it if need be. The point being, because it's a cube root, it's continuous from negative to positive infinity. So f is a cube root. It's continuous from negative to positive infinity. Therefore, it's continuous in the given interval of -4 to 5. So we are going to repeat the process by finding f prime, and f prime is very simple. 2/3 x plus 3 to the power of 2/3 minus 1 or -1/3 times the derivative of the inside, which is 1. And I didn't write that. You can write times 1 if it's important. So times 1, okay, because the derivative of the inside. And you rewrite it as follows. Because -1/3 goes down, becomes positive, or you can write a cube root. Either way is fine. Or you can write this as a 2/3 cube root of x plus 3. It's the same. So now we are going to go with the first step and say, well, f prime equals 0. A fraction is 0 when the top is 0. So when you set this equal to 0, there is no solution. Why is that? And again, over 5. Why is that? Because if you have any number, positive, negative, small, large, makes no difference. It doesn't involve x, can't be 0. But the second part where it says f prime doesn't exist, a fraction doesn't exist. A fraction is undefined. When the denominator is 0, in which case x becomes negative 3. So a quick recap. We find f prime. To set it equal to 0, since it's a fractional format, the top is 0, cannot be, doesn't give us solution. The bottom, the part that says does not exist, give us a solution. Is negative 3 in between? Yes. So negative 3 is an element of that. We are going to plug in A, this is C, and then B, and evaluate it. So I give you the answers. And just for the evaluation, I will show you a couple of them. For example, negative 4, and it's easier to go with that. So plug in negative 4 into this one. So if I put negative 4, if I put negative 4 here, I get cube root of, maybe I write it in front of it, cube root of negative 4 plus 3 squared minus 5. So I hope you see that this is cube root of negative 1, which is negative 1. Square it becomes positive 1, minus 5 becomes negative 4. So that's how you arrive at. Negative 3 is very simple. For negative 3, you get cube root of negative 3 plus 3 squared minus 5, which is 0 minus 5, because negative 3 and 3, they add up to 0. And if you plug in 5, so I'm not going to, so if I plug in 5, I get cube root of 8, right? 5 plus 3, 8 squared minus 5. Cube root of 8 is 2. 2 squared is 4. And we get negative 1. It's very easy to calculate, class. So what's the answer? Well, the largest number, since all of them are negative, this is the absolute max at this pair. The smallest number in this one, absolute mean at this pair. And the way you answer it, you want to pay attention to the question. Sometimes they ask you for the pair. Sometimes they just ask you for the absolute max. Sometimes they just ask you for the x coordinate. So just answer accordingly. All right, we want to find the absolute max and mean for this in the given interval. First and foremost, we have to discuss the continuity. This is a rational function. A rational function, you set the denominator equal to 0, you exclude that, and it becomes its domain. If you set x plus 2, x squared plus 2 equal to 0, it's never 0, because this is x squared and this is a positive value. Since it's okay, let me write that. X squared plus 2 equals 0, that gives us no solutions. So it's continuous from negative to positive infinity, although it's a rational number. And therefore, it's continuous in the given interval of 0 to 4. Now we are going to go with differentiation. And to do the differentiation, we're going to call this f, we're going to call this g, and this is f prime g. minus g prime f over g squared. See, I write the formulas and I follow it. This is the quotient rule of differentiation. So 1 times x squared plus 2 minus the derivative of the bottom is 2x times x. And then I just write the bottom in a parenthesis and square. Now all I have to do is simplify. So let's do that. X squared plus 2 minus 2x squared. Put these two together. This is what we have. Now, f prime 0. F fraction is 0 when the top is 0. Minus x squared plus 2 equal to 0. That means x squared is 2. That means x is plus minus square root of 2. I'm assuming we have no problem with that. F prime doesn't exist. A fraction doesn't exist when the denominator is 0. And we already established this denominator couldn't be 0. If you raise it to the power of 2, can't be 0 either. So there are two answers. And by the way, square root of 2 is about 1.41. But even if you don't know that, negative square root of 2 is not in between. So square root of 2 is the only number in between the given interval. So we can use A, B, and here's C. So we are going to evaluate them. If you plug in 0, I hope you realize you get 0 over 2, which is 0. If you plug in square root of 2, the top is square root of 2. The bottom is square root of 2 squared, 2 and 2, 4. So square root of 2, 4. If you plug in 4, you get 4 over 16 plus 2, 4 over 18, which is 2 over 9. So this one, you get 4 over 18, and then you simplify. Okay, everybody? All right. Now, you may not know that this is larger than this one. You should recognize if you multiply 4 by 2, let's say it's almost 9. This is 1.41 times 2 is 2.8 larger. So this is the largest number. But if you don't, change this to a approximation in using decimal, about 0.35, and this is 0.22. So largest value is this one. Smallest value is this one. And here's the writing. Absolute max is square root of 2 over 4. Or 0.35 at this pair, precise, and absolute mean is 0 at this pair, 0, 0. Pretty straightforward, everybody. So far, we've had only one critical point. I want to look at a case where we have more than that. Again, we are repeating the same concept. First and foremost, so find the absolute max and mean values of f on the given interval, where f of x is x squared minus 1 quantity cubed, in the interval of negative 1 to 2. First, what type of a function do we have? This is a polynomial of degree 2 times 3. 2 times 3, or 6. And it's continuous from negative to positive infinity. Therefore, it makes it continuous in the given interval of negative 1 to 2. So this is extremely important to understand. So that means now I can use the methodology of the extreme value or closed interval theorem. So I need to differentiate first. So in order to find CPs, I'm going to differentiate, or f prime of x, which means I'm going to put the 3 in front, times x squared minus 1 to the second power. And by the chain rule, the derivative of the parentheses is 2x, and I set this equal to 0. By the way, you can rewrite it or not. If we were to rewrite this, it would become 6x times x squared minus 1 squared. Okay. Actually, if they said what is f prime, you have to rewrite it in this fashion. But if you set this equal to 0, it's easy to see that this one is 0, so it becomes 0. This one is 0, x is plus minus 1. So there are three answers. Now, is negative 1 in between? Well, negative 1 is one of the endpoints, so that's fine. Positive 1 in between, yes. 0 in between, yes. So we're going to use minus 1 and 2 as A and B, and we are going to use 0 as well as 1. Those are easy calculation. For example, if I plug in negative 1, this becomes positive 1 and 1 cancel each other and to the power and becomes 0. So this becomes 0. If I plug in 1, becomes 0. So these two give us 0. If I plug in 0, I get negative 1. Cube it, becomes negative 1. If I plug in 2, square it becomes 4. Minus 1, 3. 3 cubed is 27. So this calculation really shouldn't be a big deal. You can do it in your head. So the largest value is 27, absolute max in the with this pair. Smallest one is the only negative number, absolute mean with this pair. All right. So that's the synopsis with a few examples as far as this section is concerned. We're going to move on to 4.2. The name is the mean value theorem. And we start with the Rolle's theorem, which is a special case of a mean value theorem. Let f be a function that satisfies number 1. It's a continuous function on the closed interval of a to b. Number 2, f is differential on the open interval of a to b. Number 3, f of a equals f of b. The endpoints have the same y coordinates. That's the meaning of it. The y coordinates for the left side and the right side are identical. That's the meaning of f of a and f of b. If that is the case, there is a number in between such that its derivative is 0. So there is some number in between the interval of a to b where its derivative is 0. That's called the Rolle's theorem. And graphs of some typical functions that satisfy the three hypotheses. There are three hypotheses you have to check before you get there. You have to check this one, you have to check this one, you have to, if all of them work, then there must be a case like that. And in each case, it appears that there is at least one point c comma f of c on the graph where the tangent is horizontal and therefore f prime is 0. If you look at these, all points indicate that because all points have f of a equals f of b. So if you have a line, in this case, okay, pick up, for example, this point and this point, right? F of a equals f of b. Look at this one, right? Look at this one, right? And if you have 2 points A and B, look at this one and look at this one. If we have it such that f of A and f of B, then what basically means is that if it's not a linear function and it's a curve because of the continuity, it must have a local max or local mean or both. That's the meaning of it. If f of A equals f of B, so if it goes up, has to come back down at some point. If f of A is equal to B, if it goes down, it has to come back at top in order for A and B to have the same y coordinate. Let's look at an example of that. All right, so Here's an example of Rolle's theorem. Let f of x be x to the power of 4 minus 2x squared. We want to find all c in the interval of -2 to 2 such that f prime is 0. And I'm reminding you that the Rolle's theorem tells us if f is continuous in the closed interval, differentiable on the open interval, and we know f of a equals f of b, then that's the case. So we have to go through all of those and see what we have here. So number one, notice f is a polynomial function. A polynomial is continuous from negative to a polynomial of degree 4. Maybe I should add polynomial of degree 4. Okay. So it's continuous from negative to positive infinity, makes it continuous from -2 to 2, because that's what we want, closed interval. And because it's a polynomial, it is also differentiable everywhere. Therefore, it's differentiable from -2 to 2. So all we have to do is to evaluate this function at -2 and at +2, see if they are equal. So if I put f of -2, if I'm interested in finding f of -2, -2 to the power of 4 is +16. Let me just quickly do that. And I hope you see that you get 16 minus 8 or 8. If I plug in 2, a +2, 2 to the power of 4 is 16, 2 squared is 4 times 2 is 8, 16 minus 8 gives you the same answer. Because number one works, all the hypotheses, number 1, number 2, and number 3, there must be a C in the interval of A to B such that f prime of C is 0. There must be. So this is read, this line segment is called such that. This is called there is. There is a C as an element of A to B such that there is. Well, let's find f prime, which is 4x cubed minus 4x. When we set this equal to 0, we can factor out the 4x. This gives you x equal to 0. This gives you x is plus minus 1. So there are 3 answers. Now, not all of them may be in the interval. If they are not all in the interval, you choose the ones that are in the interval of -2 to 2. -2 to 2. It so happened all of it, -1, 0, 1, all of them are in the interval. Therefore, in the interval of -2 to 2, the derivative is 0 at each of these x values, -1, 0, and 1. And if you look at the graph, here's the graph of x to the power 4 minus 2x squared. It's fairly basic. Look at what we have here, number 8. I hope you notice at -2, we have number 8. At +2, we have number 8. That's what we showed. We know the continuity, differentiability. And at points -1, 0, and 1, we must have f prime of x equal to 0. Notice at -1 is this point, at 1 is this point, and look at this horizontal tangent line. So this is the point, x equals -1, which we have a horizontal tangent line. Also look at this one. The same thing. And that's the finale, f prime of c equals 0. All right, let's look at the mean value theorem. Let f be a function that satisfies the following. Number one, the same as the Roche theorem. It's continuous in the interval of a to b. F is differentiable on the open interval of a to b. So far, just like before, we don't have the third part as we had in the Roche theorem. In the Roche theorem, the third part says f of a must be equal to f of b. We don't have it here. Then there is a number c in the interval of a to b such that f prime is f of b minus f of a over b minus a. We want to know the meaning of the whole thing. So take a look at the concept by looking at this graph. So we have a continuous function from a to b. So those are a to b. And when we connect the two, this is called a secant line. There is a tangent line parallel to secant line that you can find somewhere in between, and that point is C. That's the concept. If the function is differentiable and continuous from A to B, and if you draw the line which is called the secant line, there must be some line parallel to that, which means has the same. So look at this. This is A f of A, this is B f of B, and the slope is f of b minus f of a over b minus a, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it represents slope of a secant line. This represents the slope of a secant line. In other words, there is a point P where the tangent line is parallel to the secant line. That's extremely important. So in short, what does the mean value theorem says? We have a continuous function in the closed interval and a differentiable function in an open interval of a to b. There must be a number c in between, somewhere in the interval, such that the f prime of c is f of b minus f of a over b minus a, which means there is a tangent line parallel to a secant line. And if you do the cross product, this one, by the way, f prime of c times b minus a becomes f of b minus f of a. I hope you see that this will result in this if you do the cross product. So that's the mean value theorem. Let's just make some sense out of this quickly by looking at an example. We have the function f of x equals 5 minus 4 over x. We want to find all c in the interval of 1 to 4 such that the slope of a secant line equals the slope of a tangent line. That's the concept of the mean value theorem. So what do we do? First, I want to show you that the general function, you can graph this easily, 5 minus 4 over x, and it looks like that. So at x equals 1, this is where it goes. At x equals 4, this is where it goes. And this is the line. We can draw the line which is called the secant line. Now, somewhere here, we have a line parallel to it, which gives us what? A tangent line. We are looking for this point, the x coordinate of this point. That's the concept here. So let's go over the process. This is a rational function, which means the domain is all real numbers except 0, because x equals 0 makes this fraction undefined. So This is a rational function, and it's continuous from negative infinity to 0, union 0 to infinity, and that makes it continuous in the given interval of 1 to 4 closed interval. And it also makes it continuous, differentiable in the open interval of 1 to 4. Therefore, there must be some point such that f prime of C is f of b minus f of a over b minus a. And remember, this is a, this is b. So a is, this is a, this is b. So f of b, that means f of 4, minus f of a, that means f of 1, over b minus a, 4 minus 1. That's the meaning of if I plug in 4 here, I get 1, 5 minus 1 is 4. If I plug in 1 here, I get 4, 5 minus 4 is 1. So the numerator is 4 minus 1 as well, and the answer is 1. So f prime of C equals 1. What do? We find f prime of x, and we set it equal to 1. That's the process. So f prime of x, I hope you see that if I want to differentiate this, I get minus 4 times minus 1, x to the power of minus 2. So positive 4, x to the power of negative 2, or 4 over x squared. 4 over x squared. We are going to set it equal to 1. We are going to set this equal to 1. And I hope you see that means x squared is 4 if I do the cross product. X squared is 4, and x is plus minus 2. There are two answers. You go back to the given interval. Is negative 2 in between? No. The only one that is in between is 2. C or x equals to this f prime of C. So why is it? Because negative 2 is not in between. There are two answers. The only acceptable answer is the one that is in the given interval of 1 to 4. Therefore, the answer is 2. We want to use the mean value theorem to show that if f prime is between 3 and 5 for all x, we want to show that f of 8 minus f of 2 is between 18 and 30. Now, bear in mind that when we look at this one, it says number 1 must be continuous, number 2 must be differentiable. The fact that says f prime is equal to either 3 or 4 or somewhere in between, that means the function is differentiable everywhere, including the interval. What interval are we referring to? Compare. This is f of b. Remember, f of b minus f of a, right? Compare this with the numerator, f of b minus f of a. So b must be 8, a must be 2. So number 1, it's continuous because of this statement. This statement that says, suppose f prime is between 3 and 5 for all x, that means it's differentiable everywhere. When it's differentiable, it's also continuous, not the other way around. It may be continuous and not differentiable, but if it's differentiable, it's also continuous. So the first two, they work. Therefore, the mean value theorem must apply. And again, we know this is the case, right? We're going to write that if this is the case, then this must be also true that this is somewhere between 3 and 5, right? F prime of C, which is f of b minus f of a over b minus a, is also between 3 and 5. According to this, we write this, and this is the case. Now, we are going to replace this with what we have here. We know a is 2, b is 8. So let's do the replacement according to this. And that is the case. Now, 8 minus 2, as you know, is 6. We're going to multiply all sides by positive 6. We can do that. So if I get rid of this, I get f of 8 minus f of 2 is between 18 and 30, and that's what we wanted to prove, and we just proved that, and that's the final answer.